Okay, today we're going to go over how to solve trig equations, and this is section 5.3, and it is NTI day 20 and 21. You may need to reference your unit circle, especially if you've forgotten a little bit of it. But on this first example, we want to solve sine x plus radical 2 equals negative sine x. Now, basically when you solve, you want to try to get the trig functions on one side and everything else on the other. So the first thing I'm going to do is put the signs all on one side. So I have radical 2 is equal to negative 2 sine x. Okay, then to get sine by itself, I would divide by negative 2. And so that leaves me with sine x is equal to negative radical 2 over 2. Now, x stands for an angle that would make that equation true. So we need to now think about our unit circle, and we want to know what angle would have a sine value of negative radical 2 over 2. So you can either reference your unit circle, or if you still have it memorized, you could use your hand trick even. I know that radical 2 over 2 is going to be at one of those pi over 4 angles, but this has a sine value that's negative. And so think about where sine is negative. And if you remember the little all students take calculus, sine would be negative in quadrants 3 and 4. So the pi over 4 angle in quadrant 3 is going to be 5 pi over 4. And in quadrant 4, that's going to be 7 pi over 4. Okay. Now, technically, those are not the only two answers, because every angle that would be coterminal to those would also be answers. So when it just says to solve, we're going to put plus 2 in pi. Besides that, because if you remember to find a coterminal angle, you can add or subtract 2 pi. So the n will just stand for any number of rotations around the circle. And n could also be positive or negative. Negative to include those angles going in the counterclockwise position. Now, most of these are going to ask you to have your angle in radian form. There were a few on Math Lab that said degree form, but you'll know when it wants degree, and I'll show you what your directions will look like there. And then also, you're going to remember that these are equations. So the nice thing about these is you're going to be able to check answers. So, for example, if you pull out your calculator, and we need to be in radian mode, and I am. If I type in the sine, then the first answer that I have is 5 pi over 4, and then plus radical 2. Okay, that gives me that answer there, and then the other side of the equation was negative sine of 5 pi over 4, and that's the same thing. Okay, then you could do the same thing with your other answer, 7 pi over 4. I'm just going to go up and copy that, change my 5 to a 7. Okay, and then go up and copy this one and change that 5 to a 7. And same thing on both sides. So that's how you'll check your answer. So that's one thing that's nice about these equations, is being able to check your answer. Okay, next example. This time we want to solve 3 tangent squared x minus 1 equals 0 in the interval 0 to 2 pi. Now, most of the problems are going to say this. So that just means that you don't have to take into consideration all those coterminal angles. And for your math lab assignment, I tried to pick, I'm thinking all in that 0 to 2 pi range. I did want you to see that +2 in pi though, just in case you ever encounter it, but I tried to keep it simple and leave it all in that range. So if that were to say 0 to 360, that's when you know you would want it in degree form instead of radian form. Okay. Now, same idea on this one. We want to get the trig function by itself first. So I'm going to solve for tangent. So that means I would add 1 and then divide by 3. So tangent squared x is equal to 1/3. Okay, then to just solve for tangent, since it's squared, I need to take the square root of both sides. Now, if you'll remember, when we square root both sides, we have to put our plus or minus. And then this is going to be 1 over radical 3, which actually rationalizes out to radical 3 over 3. Now, where is tangent equal to radical 3 over 3 and negative radical 3 over 3? Okay, well, you know that is going to be one of your ordered pairs. It's either the 1/2 radical 3 over 2 or the radical 3 over 2 comma 1/2. Tangent's y over x, so it's actually going to be the one that has the radical 3 over 2 comma 1/2. So that's going to be at all the pi over 6's. So I have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now, for the next couple of examples, we're going to have to use a little bit of factoring in order to be able to solve. So on this one, we're going to solve the cotangent of x times the cosine squared x is equal to 2 cotangent x. Okay, the reason I know I'm going to need to factor is because on this one, do you see how it's different than the other two in the terms of we have 2 different trig functions going on? Okay, that's kind of an indicator you're going to have to do a little more to it. So when I want to factor, just like with a quadratic or anything else, we want to make the equation equal 0. So I need to move that 2 cotangent x over. And I'm sure y'all can hear my dog barking. Jack just left the house, and this is his dog, and she's not real happy that she didn't get to go with him. Hopefully she'll stop soon. Okay, so these two terms, when I look at those, there's a GCF. See how they both have a cotangent x in common? Okay, so I'm just going to pull that out as the GCF. When I pull that out, I have cosine squared x minus 2 equals 0. Okay, so now we're going to set each of these equal to 0. So once you've set your factors equal to 0, first of all, we want to look at the cotangent x equals 0. Where does your cotangent value? Oh, and I forgot this part of the directions. This should say in 0 to 2 pi as well. Sorry about that. Okay, so the cotangent, where does cotangent equal 0? Well, cotangent is x over y, so if it's going to equal 0, your x needs to be 0. So that's going to be at pi over 2 and at 3 pi over 2. Then for the cosine squared x minus 2 equals 0, that's going to be cosine squared x equals 2. So cosine x would equal plus or minus, because we'd have to square root both sides, here and here, so plus or minus radical 2. So that means, where is your cosine value equal to a positive or negative radical 2? Okay, well cosine is x, and if you remember when we made our circle, the largest x value was 1, because that's the radius of the circle. Well, radical 2 is more than 1, so this one's not going to give me an answer. The only thing I've got is right here, because cosine of x equals plus or minus radical 2, that would be undefined. Okay, so my answers are pi over 2 and 3 pi over 2. Okay, another factoring problem. This time we want to solve 2 sine squared x minus sine x minus 1 equals 0 in the interval 0 to 2 pi. Okay, so we want to think about this one in terms of a trinomial quadratic. Okay, there's not a GCF. The first two terms have a sign, but the third one does not. So if we think of it in terms of a trinomial that's a quadratic, then we should be able to factor it like a FOIL problem. So this is in this form, and if you were trying to factor 2x squared, whoops, that shouldn't have a squared. If you're trying to factor 2x squared minus x minus 1, that's going to factor into 2x and x, and then minus 1 and plus 1. Okay. All right, so for this problem, we don't have x, we have sine x. So I'm going to write this as 2 sine x plus 1 times sine x minus 1. Okay, now that we have it in factored form, we're just going to set our factors equal to 0. So my first factor is going to be sine x equals negative 1/2 once I solve that for sine. And then my other equation is going to be sine x equals 1. Okay, where on your circle does sine equal negative 1/2? Okay, sine is y, so where is y? Negative 1/2. That's going to be in quadrants 3 and 4. So we're looking at 7 pi over 6 and 11 pi over 6, because that's where the y value is negative 1/2. And then where is sine equal to 1? Well, y is equal to 1 at pi over 2. So those three are your answers. Okay. Now, just like we saw with that very first example, you can check those on your calculator, and I recommend you just trying that on one of these examples or a homework problem or two. That way you'll know how to check them on your test. But you would need to substitute 7 pi over 6 in for the x's and make sure that's equal to 0. Then do the same thing for 11 pi over 6, and then do the same thing again for pi over 2. Okay, next we want to solve 2 sine squared x plus 3 cosine x minus 3 equals 0. Now this looks a lot like the last example. However, once I kind of look at things a little closer, the difference is going to be this one is in terms of both sine and cosine. Our last example was a trinomial, but it had the same trig function instead of two different ones. So what I need to do is rewrite this all in terms of one trig function. Okay. So think back to your identities for this. I know that I can write sine squared as 1 minus cosine squared. So if I change sine squared to 1 minus cosine squared, I just need to drop the 2 in front, and then now I have the equation all in terms of cosine. So I just need to distribute and rearrange my terms and then see what we can do from there. So 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. And then I have like terms of 2 and negative 3. Okay, and now I have a trinomial that's a quadratic. It's all in terms of cosine, so I should be able to factor. Now, I don't like to factor with a negative in front, so I'm going to go ahead and just multiply through by -1. That way I can have a positive in front of my cosine squared term. So that's just going to make the 3 cosine x negative and the 1 positive. Okay, why don't you kind of pause this and see if you can finish from here, because this at this point looks just like that last example. Okay, and then we'll compare answers. Okay, so you should have pi over 3, 5 pi over 3, and 0. And yep, I forgot again to put this little n 0 to 2 pi part. Okay, now the last couple of examples are going to have what we call a multiple angle. So on this first one, we want to solve 2 cosine of 3x minus 1 equals 0 in the interval 0 to 2 pi. Now, this is the part that makes it a multiple angle, which is going to make it a little different at the end when we go to solve. Okay, same idea. We want to get the cosine by itself. So that's going to actually be the cosine of 3x for this one. So that means I'm going to take that minus 1 and add it, and then divide by the 2 in front. So that gives me cosine of 3x equals 1/2. Now, where on your unit circle is cosine equal to 1/2? That's going to be at pi over 3, and it's also going to be at 5 pi over 3. Now, the difference is that's not my answer. That's equal to 3x because of that 3 in front of our x this time. This is also equal to 3x. Now, when I go to get x by itself, what am I going to have to do with the 3? Okay. So when you divide by that, that's going to make it a much smaller angle. So this 5 pi over 3, we'll look at that one first. Okay, 5 pi over 3 is in quadrant 4. But when I divide by 3, that gives me 5 pi over 9. Okay, 5 pi over 9 is just barely in quadrant 2. It's really close to quadrant 1. Okay, so when we're looking at finding all of our answers in 0 to 2 pi, we could be missing some. So even though it doesn't say to just solve, we still want to include that coterminal angle part, and I'll show you why here in a minute. Okay, so we know that to get the x by itself, we're going to divide by 3. Okay, and dividing by 3 is the same as multiplying by 1/3. So I'm going to do that just so that you can, I think it's a little easier to see the fraction and stuff when you do that. So multiplying everything by 1/3, x is equal to pi over 9 plus 2n pi over 3. And then here, x is equal to 5 pi over 9 plus 2n pi over 3. Now, when n is 1, that means just one rotation around the circle. Okay. Actually, let's start with 0. When n is 0, okay, that means you're just looking originally around the circle, and so that's just going to be pi over 9 and 5 pi over 9. Okay. When n is equal to 1, then that's going to mean that this is 1 and that's 1. Okay. So that's going to make this pi over 9 plus 2 pi over 3. Okay. Well, pi over 9 plus 2 pi over 3, well, 2 pi over 3 would be what, 6 pi over 9 when we want to get a common denominator? So 6 pi over 9 plus pi over 9 is 7 pi over 9. Okay, that's still less than 2 pi, so I have to include that. Okay, same idea here. This would be 5 pi over 9 plus 2 pi over 3. So 5 pi over 9 plus 2 pi over 3, well, just like earlier, we changed 2 pi over 3 to 6 pi over 9. 6 plus 5 is 11, so we also have 11 pi over 9. So I have those answers, and I have these so far. Okay. Well, 11 pi over 9 is still less than 2 pi. What happens when we let n equal 2? Well, when n equals 2, then I'm going to be taking pi over 9 and adding 4 pi over 3. Because 2 times 2 would give me 4. Okay, my common denominator makes 4 pi over 3, 12 pi over 9. 12 plus 1 is 13 pi over 9. That's still less than 2 pi, so that works. Okay, when I let n equals 2 on the next one, then I'm going to have 5 pi over 9 plus 4 pi over 3. Once again, we'll change this to 12 pi over 9. 12 plus 5 is 17. So that's 17 pi over 9. Okay, do we have to try n equals 3? Okay, well, 17 pi over 9 is really close to 2 pi because 2 pi would be 18 pi over 9. So since it's just one away, you're really not going to have to substitute in 3. But those 6 answers are going to be your answer. Okay, so I know that gets a little complicated, but that's the only time you really have to worry about it is when you have this multiple angle thing here. Okay, and actually, let me show you one more multiple angle problem. And on this one, you don't have to worry about it as much. I'll show you why here in just a second. This is 3 tangent of x over 2 plus 3 equals 0. Okay, now how do I know it's a multiple angle problem? Look after the trig function, see how that's x over 2? Okay, so that's what, since it's not just x by itself, that's what's going to make it a little different. So I get the tangent by itself by subtracting 3 and then dividing by 3. So that's going to make it tangent of x over 2 equals -1. Subtract 3 and divide by 3. Okay, where does tangent equal -1? Okay, well, tangent's y over x. So in order for y and x to cancel out and give you a 1, it's going to have to be one of our pi over 4s. Okay, but we only want the negative. So that's going to be the quadrant 2 angle and the quadrant 4 angle. Okay, well, the quadrant 2 angle is 3 pi over 4. The quadrant 4 angle is what, 7 pi over 4? Yeah, 7 pi over 4. Okay. Now, on this one, I'm not really going to have to worry about the plus 2 in pi because I'm setting this equal to x over 2. That was my multiple angle. But to get x by itself, what are you going to do to get rid of that over 2? Yeah, you're going to multiply by 2. So if I'm multiplying instead of dividing, it's going to put it past that 0 to 2 pi range that we're looking at. Okay, so when I multiply this by 2, this one becomes x equals 3 pi. Nope, that's not right. Multiplying 3 pi over 4 times 2 gives me what? Three pi over 2? Yep. Okay. And then over here, when I multiply by 2, that gives me x equals 7 pi over 2. Well, that's already kicking it past that 2 pi range. Okay, so this is going to be my only answer here, 3 pi over 2. So you only have to worry about this on the multiple angle ones, but really just the ones where you end up having to divide, like on that last one. We had to divide, so it made my answer smaller. And I forgot to put this again, but here we go, in 0 to 2 pi. Okay. On this one, even though it was a multiple angle, we didn't really have to worry about all those weird little scenarios with the 2 in pi's because we're multiplying, and so it kicks it into that 0 to 2 pi range. It kicks it out really fast. Okay, so it's just 3 pi over 2. Okay, that's the end of solving equations. I know these notes were kind of long, but that's one reason why I made this assignment for both days, because I figured it was going to take you a while to write through the notes. So you might want to just start the Math Lab and then see about finishing it up tomorrow, or kick it all out of the way now, and then you won't have an assignment for the next day. Talk to you guys later.